Hello everyone, Math Guy here. In this video, I'm going to be doing problem number 63.2. Let me write that down. 63.2 from the Stanford Mathematics problem book. The question states, prove that the following expression is divisible by 360 for n equals 1, 2, 3, and so forth. And the expression we've got here is f of n is equal to n squared times n squared minus 1 times n squared minus 4. Now, looking at this just once, I can tell that we can easily expand this guy and simplify it a bit further. So let's do that. So f of n is equal to n times n minus 2 times n minus 1 times n plus 1 times n plus 2. And this is because this guy and this guy make up n squared minus 4. This guy and this guy make up n squared minus 1. And this guy and this guy make up n squared, of course. So now, let's look at this in a bit more detail. So we have f of n equals n times n minus 2, n minus 1, n plus 1, and finally n plus 2. So this is just the product of 5 consecutive integers. 5 consecutive integers. Now, the real problem begins now. So 360 is equal to 8 times 5 times 3 times 3. So that is equal to 2 raised to 3 times 5 times 9. Okay, so this is equal to 2 raised to 3 times 5 times 3 squared. And now we've got a much clearer picture of what's going on. So we have 5 consecutive integers here. This means that amongst these guys, there's going to be exactly one which is a multiple of 5. And therefore, this expression is divisible by the 5 which constitutes the 360 we have here. Also, amongst these 5 integers, there's going to be one that's a multiple of 2, and there's going to be another which is a multiple of 4. So these two, we've accounted for these two. These two are going to be divisible every day of the week. Now, the problem is here. So first off, let's say n is equal to 3k. n is some multiple of k. So over here we have n times n. Obviously, if you multiply 2 multiples of 3, you're going to end up with at least a multiple of 9, right? And therefore, we've accounted for this guy as well. Hooray. But what if it's not a multiple of 3? Now, in this case, there's only 2 options. N can be 3k plus 1, or n can be 3k plus 2. Now, if n is equal to 3k plus 1, then n minus 1 will surely be equal to 3k, right? Furthermore, n plus 2 will also be equal to 3k. Not necessarily the same k, but it's still a multiple of 3. And if n is equal to 3k plus 2, in this case now, n minus 2 will of course give us 3k, and n plus 1 will also give us 3k. Again, these two k's will never be the same, but it's all we're looking for is the fact that n plus 1 is indeed a multiple of 3. So we've proven that amongst those 5 integers, let me write that down again, f of n equals n times n minus 2, n minus 1 times n plus 1, and finally n plus 2. Amongst these 5 integers, we showed that somewhere there's a multiple of 8, there's a multiple of 5, and now we've finally shown that no matter how you choose your n, either this guy and this guy will both be a multiple of 3, or this guy and this guy will be a multiple of 3, or these two will be multiples of 3. And therefore, we've proven that amongst these six integers, there's basically going to be some multiples of 360. And therefore, When you divide it by 360, you get left with some integer. Let's just call it c. Therefore, the proof is complete. I hope you enjoyed the video. Have a great day.